I'd like to take a closer look at this circuit, so I'm going to do something called single stepping through the circuit. So what I'm going to do is I'm going to press pause. So now I'm just going to single step through the circuit, and it's going to simulate until state change. So starting out, our pressure bypass valve is set to 3000 on the power unit, 2000 on the hydraulic valve. We have a 5 psi cracking check valve here. We have our pressure switch set to trigger at 2000 psi. Our motor has no external torque on it, and our pump is going to start running at 3000 RPM. Okay, I'm going to simulate until state change. Turning on flow values, we have initially we just have some flow filling up the hoses. We're starting to build up pressure. We have about 600 psi on the motor. The motor has not started spinning yet. Okay, now we've got 3000 psi on the motor. We have a little bit of flow through our bypass valve, and the motor's begun to spin. I'm sorry, we don't have any flow through the bypass valve yet. You'll notice that we have 2.6 GPM coming into the hose, but no flow out of the valve. Okay, our pressure rose a little bit. Now you can see the system is remaining at 3000 psi manifold pressure. Our motor's up to speed. We have full flow through the motor, no flow through our pressure bypass valve, full flow through the tandem center of the cylinder. Not much happened there. Looks like our pressure is starting to drop. And there we go. Motor's up to speed. We have 260 psi manifold pressure. Since our pressure dropped here, we've got a little bit of flow coming from this hose. That's really nothing. The motor's pushing a little bit more flow through the valve because it's up to speed, and so now we've got a little bit of a slight pressure variation. It's dropping here. You look at this valve, this pressure gauge here. Pressures are dropping, and now it looks like the motor speed is dropping. The motor is spinning a little bit faster than the pump flow rate would allow, so now it's just going to kind of wind down and even out at that speed. I'm sorry, the flow is going to wind down. We also have a little bit of a pressure differential between this cylinder valve here, 247 versus 242. And now that's kind of just going to bounce back and forth as the motor matches the pump, and nothing's going to happen. Our system is kind of, there's nothing else we can do. It's balanced out. So we're just going to kind of get a little bit of a speed variation there. So at this point, our motor's up to speed. We're ready to drop some soil in. So right now we're in the cylinder home position, which corresponds to loading soil and ejecting. Loading soil into the drawer and ejecting. So we've got soil in the drawer. Let's extend the cylinder. Okay, so we've changed the state. Let's see let's simulate until the next state change. We're getting some flow into the cylinder, just beginning. And now we're getting some flow out of the cylinder. The pressure here on the cylinder valve has increased, so our check valve is opened, and we're getting flow starting to go into the check valve for the motor. Starting to see higher flow out of the cylinder. Cylinder is extending. Not a whole lot to see here. 350 psi on the cylinder valve, 350 psi on the motor. Some very small pressure variations. We'll just skip through all that. There we go. So now it looks like our cylinder has bottomed out. We're going to expect to see some pressure increase here as the fluid has nowhere to go and this pressure relief valve is not yet opened. And our pressure switch is not yet signaled. So there we go. Our cylinder is definitely bottomed out. Our pressure has increased on the cylinder valve. And our pressure switch just closed. So now we've just gotten the signal that we need to switch this valve. So I'm going to switch the valve back to center position, simulate till next state change. We still have 2000 psi, and still pressure's dropping a little bit. There we go. Pressure has dropped to 250 psi. Motor pressure increases, and now that we've gotten our cylinder all the way to the end of its travel, the load is going to increase. We've just dropped a bunch of soil in. Let's put a negative 20 Newton meter load on the motor. So now we should see motor PSI actually increase. And it looks like in this state, which is we can't go any farther. We oscillate between looks like 700 and 2000 psi due to the load on the motor. Okay, now this load will probably drop a bit. Let's take it down to negative 10. And our pressure for our system drops. And at this point we probably mixed the soil up pretty good. So let's retract to the eject position. Switching the valve. We begin to see some flow. Pressure rises. Motor speed stays around the same. There we go. All the flow goes, the cylinder retracts fully. 1500 psi manifold pressure. I'm going to drop this external torque to negative 5 as dirt is leaving the chamber. Our pressure switch still has not triggered yet. There it goes, just triggered. Last time I switched it immediately. This time I'm going to wait a second. And you can see now that we've got 2100 psi and full flow, 13 1/4 GPM through our pressure bypass valve. Now I'm going to switch the cylinder valve back to center. Pressure drops slightly, but flow, oh look at that, we actually have 32 GPM through the cylinder valve. I'm not sure where that's coming from. 20 GPM leaving the motor. That's interesting. 52 GPM entering the tank. And I'm not sure why that is. And looks like that's going to stay with us for a moment. So a real big flow spike. Yeah, no idea where that's coming from. But I would anticipate that that actually wouldn't happen. You wouldn't get 30 GPM through this valve because the orifice is too small. I would assume that this actually would open up here, and actually that may not happen if we set a more realistic value for hydraulic resistance for this valve. So where are we? We've got cylinder in the home position, which means we're ejecting soil, and eventually this load is going to drop to 0. Stepping through some small pressure changes. And now the motor is kind of balancing out with the pump. And we're back to where we started. So that's one full cycle of the machine. And now I'm going to show the shutoff condition. What I'm going to do is turn our pump RPM to 0 and simulate. So our pump output has dropped to around 2 to 3 GPM. We get a little bit of vapor pressure here, -5 PSI. Our motor is freewheeling. We've got full flow through our motor, and that's about all we're gonna get. There are no more steps. So this motor is just gonna slowly wind down as flow circulates through here with a -5.58 PSI manifold pressure. And I'm just gonna hit play. And yeah, our motor is just going to wind down kind of slowly. We don't have a braking circuit installed here. Could do that, it'd just get more expensive, but I don't think it's necessary. You know, while we're winding down, maybe switch the valve. But that won't really do anything. There's no flow, you're just getting flow right in this circle here. Okay, thanks for watching. I hope the audio comes out okay. Sorry about my voice, I'm sick.